In this video, we are going to be dealing with the West African Examination Council, and precisely on the West African Senior School Certificate Exam. Chemistry Paper 2. This paper is 3 hours and is made up of 2 sections or 2 parts. Part A and Part B. But before we continue, I want to thank those of you who have taken your time to subscribe to our channel. And for those of you who haven't subscribed to our channel, please like this video, share to other learners, and most importantly, take some time and subscribe to our channel so that other subsequent solved papers, you'll be having them. Thank you for taking your time to subscribe to our channel. Let's get started. We will be starting with May-June 2013. May-June 2013. Part A, Objective Test. This is 1 hour. It carries 50 marks. Answer all the questions. Each question is followed by 4 options, lettered A to D. Find the correct option for each question and share it in pencil on your answer sheet. The answer space, which bears the same letters as the option you have chosen. Give only one answer to each question. An example is given below. Which of the following elements react with water? You have A is carbon, B is iodine, C is sulfur, D is sodium. The correct answer is sodium, which is lettered D, and therefore answer space D would be shaded. If you look at it, that is how it is being shaded, and that is how you do it on your exam paper. Think carefully before you shade the space. Erase completely any answer you wish to change. Do all rough work on this question paper. Now answer the following questions. Answer the following questions. 1. The atomic theory was put forward by A. Avogadro, by Avogadro. B. By Dalton. By C. Gay-Lussac. And by D. Rutherford. So you know that the Dalton atomic theory, from the name Dalton atomic theory, it was put forward by Dalton. So it is Dalton who did that. So our answer for this is B. Our answer for number 1 is B. And in order to shade B, this is how we are going to do. This is how you will shade on your answer sheet. That is the answer B. The answer is B. Question number 2. A balanced equation is based on the law of A. A balanced equation is based on the law of A. Chemical equilibrium. B. Conservation of mass. C. Definite proportion. D. Multiple proportion. It should be remembered that a balanced equation, for the law of conservation, listen, the principle of atoms conservation, The principle of atoms conservation states that the total number of atoms of each element in reactants must equal the number of atoms of that element in products. Remember that this is how the law of mass conservation was derived. That the total number of atoms of each element in a reactant must be equal to the number of atoms of that element in the product. That is balancing equation. And this is how the law of mass conservation was derived. So now, getting back to our question, a balanced equation is based on the law of what? It is not based on the chemical equilibrium. It is not based on the definite proportion. It is not based on the law of multiple proportion, but it is based on the law of conservation of mass, which is B. Now we go to question number 3. Question number 3. The number of atoms in 1 mole of a substance is equal to number of atoms in 1 mole of a substance is equal to A, atomic number, B, Avogadro's number, C, atomic mass number, and D, oxidation number. What is Avogadro's number or Avogadro constant? That's the number moles of a substance in. We said the number of atoms in 1 mole of a substance. Number of atoms in 1 mole of a substance is equal to the Avogadro constant. The Avogadro constant is equal to the number is the number that is used to calculate is the number which is equal to the number of particles. And the particles are what? The number of electrons, the number of atoms in a reaction. So you can use that to calculate. Because 1 mole of a substance will contain 6.02 times 10 to the 23rd power, which is the Avogadro constant. So it will contain that number of atoms. 1 mole of a particular substance will contain 6.02 times 10 to the 23rd atoms, or 6.02 times 10 to the 23rd electrons. So 1 mole of a substance will contain that number, and that number is equal to the number of atoms. So it is the Avogadro's number, or what is usually called the Avogadro constant. So the answer is B. Number 3 is B. Okay, number 4. The noble gases are A, diatomic, B, monoatomic, C, polyatomic, D, triatomic. Of course, you have never seen a noble gas, let me say helium, neon, argon, being a diatomic. Diatomic, it has 2 atoms. It does not have 2 atoms. It's monoatomic. All noble gases are monoatomic. They are not diatomic. They are not polyatomic. They are not triatomic, but monoatomic. So our answer for 4 is B. Let's go to question number 5. Question number 5. An element Q, which is a mass number of 23 and a proton number of 11, has a valency of 1, a valency of 2, a valency of 3, a valency of 4. It will not have a valency of 4 because it will have the first shell will have 2 electrons. The first shell will have 2 electrons. The second shell is going to have 8 electrons. That is already 10. Then the last shell will have 1 electron. So the valency for an element like this will be 1. The valency will be 1, and our answer here is A. Question number 6. The classification of element in the periodic table is based on A. Mass number, B. Number of neutrons, C. Number of protons, D. Relative atomic mass. Our fellow learners, it should be recalled that on the periodic table, elements are arranged in order of their increasing proton number. The proton number, or what we call the atomic number. So elements are arranged in order of increasing proton number. So our answer here is not the mass number, it is not the proton number, it is not the neutron number, it is not the relative atomic mass, but it is the number of protons. So C is, our answer for 6 is C. Okay, let's go to question number 7. Question number 7, we will have which of the following statements about the periodic table is or are correct? 1. Atomic radius increases across the period. No. Atomic radius does not increase across the period, because across the period the nuclear charge is increasing. As the nuclear charge is increasing, outer electrons are drawn because of the force of attraction between the valence electron and the nucleus. The force of attraction between the valence electron is increasing as you go across the period. So outer electrons are drawn towards the nucleus, and atomic number is what? It's going to be decreasing. Atomic radius is going to be decreasing. 2. So one is not right. 2. Electron affinity decreases down the group. Yes, electron affinity is decreasing down the group. Those of the group are highly have high affinity for electrons, more than those down the group. So 2 is right. Then 3. Ionic character increases across the period. Ionic character is not increasing across the period. 4. Ionization energy decreases down the group. Yes, ionization energy is decreasing down the group. Why? Ionization energy is the energy required to remove 1 mole of electron from 1 mole of gaseous atom to form 1 mole of gaseous ion with a unipositive charge. So now, as you move down the group, the shell, the atomic radius, or the atomic radius is increasing, or the outer electrons, they move further away from the nucleus. For that purpose, electrons outside the valence electrons are easily removed, because the force of attraction between the nucleus and the outermost electron is decreasing. Once more, as you move down the group, the atomic radius increases. The distance between the outermost electron and the nucleus is increasing. The force of attraction between the outermost electron and the nucleus is also decreasing. Therefore, energy required to remove 1 electron from, or the first electron from the outermost electron is, from the outermost shell, is low. In that case, we say ionization energy is decreasing as you move down the group. So our answer will be 2 and 4. So let's go to our answer section. 2 and 4. 2 and 4. So A is the right answer. A is the right answer. For question number 7, we have A. Okay, let's go to question number 8. An element M forms a compound MCl5 in which group of the periodic table is M? Which group of the periodic table is M? If you look at it critically, we have MCl3. The element should belong to group 5 of the periodic table. It should belong to group 5 of the periodic table. An example of MCl5 is like phosphorus pentachloride, and that is group 5 of the periodic table. And the group 5, answer for group 5 is C. So our answer for for 8 is C. Let's go to question number 9. Question number 9. Which of the following instruments could be used to dictate the presence of isotopes? We don't use a cathode ray to dictate isotopes. We don't use electron microscope to dictate isotopes. We don't use the Geiger-Müller counter to dictate isotopes. We will use but the mass spectrometer. Is the mass spectrometer that is an instrument that is used in the laboratory for in analyzing in analytical chemistry. The mass spectrometer, analytical chemistry. So mass spectrometer is the instrument that is used to detect the presence of isotopes. So 9 is D. Question number 10. Which of the following noble gases has electron structure similar to that of nitrogen in ammonia? Of course, nitrogen in ammonia, nitrogen has atomic number of seven, or proton number of 7. Nitrogen has a proton number of 7. So if we are writing the electronic configuration, we will have helium, which is 2, 2s2, and 2p3. So the last electron of nitrogen ends in the p orbital. Now, it starts with helium and ends in the p orbital, in 2p orbital. Now, we go to neon. Neon, it starts with helium. And neon is 10. So this is 2, which is helium plus 2, 2s2, and 2p6. It ends in the 2p orbital. That is 2p orbital. Argon starts with, neon. Argon is 18. So neon is 10, then 3s2, and 3p6. Helium is just 2, which is 1s2. So you look, the one that is similar is neon, because all of them are ending at in the 2p orbital, even though neon has 3 electrons more than nitrogen, or even though neon has a full p orbital more than nitrogen. So all of them end up in the 2p orbital. So the one that is similar is neon. And neon, if we go to where neon is C. Neon is C. C is, that is question number 10, is C. Neon is C. I'll go to question number 11. Question number 11. Which of the following electron configuration is the most stable? Electron configuration, which is the most stable? If you look at it critically, we have argon 4s1, 4s1, then the second one is 4s2, 4s2, 4s2. Then we have a 3d5. So 4s1 is half filled. 4s1 is half filled. The d orbital here is also half filled. So now there is 4s2 which is filled, and 3d which is filled. So which of the following electron is the most stable? There are 2 stable electron configuration here. That is the one that is half filled and the one that is completely filled. But they are talking of the most stable. The most stable is the one that has a complete s a completely filled s orbital and a completely filled d orbital, which is a d. So our answer for 11 is D. Let's go to question number 12. Question number 12 will have to deal with question number 12. We say, which of the following statement about 2s and the 2p orbital is correct? 2s and the 2p orbital is correct. Okay. Okay. A. Electrons in the 2p are more strongly attracted to the nucleus. Remember the s electrons, the s orbital electrons are closer to the nucleus more than the p orbital. The p orbital are at a higher energy level than the s orbital electrons. So the answers are: electrons in the 2p are more strongly attracted to the nucleus. That answer is not right. Is not correct. B. They have the same maximum number of electrons. No. S has two, while S has 2 electrons. Meanwhile, P has 6 electrons. So that one is not appropriate. C. They have the same maximum number of sub orbitals. That is not also appropriate. D. The 2s has a lower energy level than the 2p. Exactly. The 2s has a lower energy level. It's a lower energy level than the 2p. So our answer is right, which is our answer D is okay. Let me share it. Okay, I've shared it. Question number 13. Covalent bonding results in the formation of, for the purpose of revision. Remember, covalent bonding has to do with sharing of electrons. Sharing of electron between two or more atoms to obtain an octet of electron, to obtain a full outermost shell or a complete outermost shell. Okay, this will usually result, of course, it will result in a molecule. It will result in a molecule. It can also result in formation of a compound. So now let's go to our question. Covalent bonding results in the formation of atoms. It doesn't work like that. B. Covalent bonding results in the formation of ions. Not appropriate. C. It results in the formation of molecules. Correct. We don't need to go further. C is our right answer. 13 is C. Question number 14. Question number 14. Question number 14 has to do with some charges, bonding charges, and especially metallic bonding. It should be recalled that in metallic bonding, the number of valence electrons, as I said, the more the number of delocalized or valence electrons, the more the number of delocalized valence electrons, the more the attraction of the electrons to the nucleus, and the stronger the metallic bond. So in any ion that have more delocalized valence electrons, ion like for example aluminum. Aluminum here has 3 plus. There are more delocalized electrons in aluminum. There are more delocalized electrons here in aluminum than in aluminum ion than in magnesium ion. And there are more delocalized electrons here in aluminum ion than in sodium ion. So for that reason, the metallic bond, because of this, there's more attraction of electrons here to the nucleus than here. There is more attraction of electrons here to the nucleus than here. So in that case, where there is more attraction, the stronger the metallic bond. So in that case, metallic bond in aluminum ion involving aluminum ion will be stronger than metallic bond involving magnesium ion, and metallic bond involving magnesium ion will be stronger than that involving the sodium ion. So that is why I said the more the number of the localized valence electrons, the more the attraction of the electrons to the nucleus, and the stronger the metallic bond. Let's get back to our question. Our question reads, the strength of metallic bond depend on the charge density of the atoms, the charge density of the atoms, the charge density of the atoms. B, position of metals in the periodic table. No. C, the number of valence electrons. And D, the total number of electrons in the atom. That is not the case. So C is the right answer because the number of valence electrons, as I told you here, the more the number of the localized valence electrons, the more the attraction of the electrons to the nucleus, and the stronger the metallic bond. So in that case, our answer for question number 14 is C. Let's go to question number 15. Question number 15 has to do question number 15. Question number 15 has to do with formation of compounds. Formation of compounds. So in this case, we are told a compound is formed when 3x combines with 8y. Determines the formula of the compound. Okay, in this case, as I told you, in the formation of compounds, there is what we call swap. We can swap, we will swap this. 3 will go to y and 8 will come to x. So the possible answer here is A. The possible answer here for 15 is A. Now, 16. Question number 16. A hydrogen compound is represented by the following. A hydrogen compound is represented by the following structure. The structure there is an ethene molecule. Ethene. That is an alkene. Now, determine the total number of shared pair. The word shared pair. Shared pair electrons in the compound. The total number shared pair. We are not told shared electrons. We are not told shared electrons, but we are told shared pair. So we need to look for the number of electron pairs that are being shared. We need to look for the number of electron pairs that are being shared. Okay, let me show you an example of a ethene molecule. This is an ethene molecule with 4 hydrogens and the carbon are now the double bond represent the 4 electrons here that are being shared. There are 2 pairs here. This is 1 pair, this is another pair, this is another pair, and this is another pair. Altogether 4 pairs. Now this is another pair here that is being shared, and this is another pair here that is being shared, making altogether what? 6 pairs of electrons that are being shared. That is shared pairs, shared pair electrons. So there are 6 pairs of electrons. So let's go to our answer. Our answer did, okay, 12 pairs, no. 12 is the total number of electrons. 10, no. Pairs of electrons, shared pairs. Now we have 6 pairs. So our answer is C. Our answer is C. There are 6 pairs of electrons that are being shared. 17. 17. Which of the following compound has the strongest hydrogen bond? If you look at a hydrogen bond is what? A hydrogen bond is the bond from when a strongly electronegative element is attached to what? Hydrogen of another electronegative element, of hydrogen that is attached to another electronegative element. So now, which of these has the strongest electronegative element? It is not methane, it is not this one, it is not this. So the strongest electronegative element here is hydrogen fluoride. And it is from this where hydrogen bonds are formed. And among all it has the strongest hydrogen bond. So our answer for 17 is A. Let's go to question number 18. Question number 18 has to do with polarization. The polarizing power of a cation is enhanced by its. The polarizing power of a cation is enhanced by its A. Small nuclear charge and small size. Not appropriate. It is not appropriate. High nuclear charge, yes, and a large charge and large size. No, it doesn't work like that. High ionization energy and a low electron affinity. No, it doesn't work like that. A D, high nuclear charge and a small size. Excellent. It is high charge and a small size that determines the polarizing power of cations. For instance, you have sodium ion, calcium ion, and aluminum ion. If they ask you which one has the highest polarizing power, which one has the highest polarizing power here, is because it is aluminum. Why? Aluminum has a very high charge, a nuclear charge, and a small size. Has just a small size. Aluminum and calcium. Aluminum is smaller than calcium, but it has a higher nuclear charge. So high charge and small size determine the polarizing power of a cation. So our answer for 18 is D. Let's go to question number 19. It has to do with some calculations. A solution of sodium hydroxide with concentrated 2.0 mole per dm cube is contained in 25 cm cube of its volume. Determine the amount of sodium hydroxide in the solution. Amount we are talking is amount, that is the number of moles. Now, you have been given the concentration of sodium hydroxide, and you have been given the volume. You have been given its volume and its concentration. You are asked to calculate the number of moles. Learners, there is a relationship here. We have moles. When we are dealing only with volumes, to have the number of moles, you will multiply the concentration that is in mole per dm cube times its volume, and the volume must be in dm cube. If not in dm cube, we have to convert it into dm cube. Then if you are given the concentration in this relationship, if you are given the concentration to look, if you are given the moles and the volume to look for the concentration, you need to divide the number of moles by the volume in dm cube. You have the concentration. Or if you are given the moles and the concentration to have the volume, what you will need to do is, to have the volume, you divide the number of moles by the concentration that is in mole per dm cube. You have the volume in dm cube. So in this case, we are looking for the amount, which is the number of moles. And we have been given the concentration and the volume. what we need to do is we need to multiply the concentration times the volume in dm cube. Since the volume is in cm cube, we need to convert it into dm cube and multiply it by the concentration. We have the number of moles. So let's go on the left. Very simple. Moles of sodium hydroxide is concentration times the volume. Now, the volume was 25. 25 to convert into dm cube, you divide it by 1,000. So 25 divided by 1,000, we will have 0.025. So now 2 mole per dm cube times 0.025 dm cube. Per dm cube will cancel the dm cube. We will be left with the moles. So 2 moles times 0.025, we will have 0.05. And if the number of moles of sodium hydroxide is 0.05, we come to our answer column here, 0.05. Our answer for 19 is D. Okay, question number 20. Question number 20. It has to do with calculation again too. Question number 20 has to do with calculation. It has to do with calculation. So here, we are told determine the volume of 0.10 mole, 0.1 mole per dm cube sulfuric acid that could be used to neutralize 20 cm cube of 0.25 mole potassium hydroxide. Well, in a neutralization or acid-base, reaction like this one, in order to calculate this, because we have been given the volume, of the concentration of the acid, and we have been given the volume of and its volume. Then we have been given the concentration. So now the concentration of the alkali. So what we need to do is we need to look for the volume of the acid. So in order to look for the volume of the acid, there are two methods. The first method that I believe you are versed with it is we can write an expression which is the first thing is write the equation, a balanced equation for an acid-base reaction. We need to write a balanced equation in order to have our mole ratios. So the first thing is write a balanced equation. When we write a balanced equation, this is what we are going to have. When we write a balanced equation, this is what we are going to have. Our mole ratio is 1 mole of an acid is reacting with 2 mole of the alkali. So now, this is the mole ratio. Now we need to write this expression, molarity of the acid, volume of the acid, divided by molarity of the base, divided by times volume of the base, equals to the mole ratio, which is the acid all over the base. This is the mole ratio. A and B are the mole ratios. So now, from here, it is understood that we have been given the molarity of the acid to be 0.1. The volume of the acid is not given. The molarity of the base has been given. The volume of the base has been given. Then the mole ratios, that is, how many moles of acid are reacting with alkali. We have for acid, we have 1, and we have for the alkali, we have 2. Now, let's make, since we are looking for the volume, we are looking for acid, volume of the acid. Let's make volume of the acid the subject. So we would cross multiply and divide everything by MA and MAA. MA and A. So VA will be equal to MB VB times A divided by MAB. Okay, now that is we are looking for the volume of A. If we substitute this value here, MB is equals to 0.25, then times VB, which is 0.20, which is 20, sorry. Then the mole ratio, which is A, which is 1, divided by MA, which is 0.110 times 0.10 times 2. And if we divide everything, we will have 25 cm cube of sulfuric acid. And if we have that, 25 cm cube of sulfuric acid, we now come to our answer column, and if we look at it, our answer column, so number 20 will be a D. 20 will be 20 is a D. 20 is a D because it is 25 cm cube. 25 cm cube. So question number 21. A volume of 100 cm cube of sodium carbonate was prepared with concentrated 0.3 mole per dm cube. 0.3 mole per dm cube. We have been given the volume, and we have been given the concentration, volume and concentration. Good. Determine the mass of sodium carbonate that was used for the preparation. The molar mass, or MR is the molar mass. The molar mass is otherwise called MR is of sodium carbonate is 106. So a simple way of solving this problem here, question number 21, a simple way of solving this problem here is this. The number of moles. I told you that from our expression above, the number of moles, since we have been given the volume and we have been given the concentration, so the number of moles will just be the concentration times the volume in dm cube. So now we need to convert it, the volume that was given here, sodium carbonate, the volume that was given here, the volume that was given here is 100 cm cube. So if we divide 100 cm cube, by 1,000 to have our volume in dm cube, we will have 0.1 dm cube. So now our concentration is 0.3 mole per dm cube. So the number of moles will be concentration times the volume in dm cube. So per dm cube will cancel the dm cube. So we are left with 0.3 mole times 0.1. When we multiply that, we will have 0.03 moles. That is 0.03 moles. Those are the number of moles. Now, to have the mass, because this is not our answer, it's just getting to our answer. This is the number of moles. To have the mass of sodium carbonate that was used, to have the mass, we will multiply the number of moles times the molar mass. And the molar mass that we have been given, or what we call MRO, is 106. So the number of moles is 0.03 moles times the molar mass, which is 106 grams per mole. The moles will cancel the per mole, and it will be 0.3 times 106 grams, and that will have 3.18. Our final answer that we will get is 3.18 grams of sodium carbonate. So number 21, our answer for number 21 will be 3.18. 3.18 for question number 21. 3.18. 3.18. 3.18 is B. Our answer for 21 is B. Is B. Now question number 22. Question number 22. Which of the following statement about matter is correct? 22. Which of the following statement about matter is correct? A. Kinetic energy of particle decrease from gas to solid. Yes. From there. Gases, they have more energy than liquids. Liquid, they have more energy than solid. In other words, more energy is needed. Energy is needed to convert solid or to melt solid to liquid. Energy again, more energy this time around is needed to boil the liquid. to gas. For energy, for the change of state, more energy, the gases, they have more energy. Gases have more energy. That is why they can move rapidly at high speed. They move rapidly within high speed because they have high energy. The kinetic energy in the particles in gases is higher than the one in the solids. I mean, in liquids. And the one in liquid is higher than the one in solid. So the kinetic energy of particle decreases from gas to solid. That one is okay. That one is right. Let's check B. The orderliness of particles decreases from gas to solid. Orderliness of particles decreases from gas to solid. No. Gases are not even orderly. They move randomly. They occupy the whole container. Gases, they move randomly and occupy the whole container and at a very high speed. There's no order in gases. Order is instead but in the solids. Particles are fixed. So the answer B is not right. Random motion of particle decrease from solid to gas. Solid to gas. Gases random motion. Solid do not they don't even move randomly. They only vibrate. Particles in a solid form, they are packed together. They have a fixed shape and they only vibrate. So that answer is wrong. D, there is increased compressibility in solid is a lie. That one is not right. So the only right answer, which the statement about matter which is correct here, is kinetic energy of particle decrease from gas to solid. A. 22 is A. Uh, 23. The movement of particles from a region of higher concentration to a region of lower concentration is referred to as what? Brownian motion? No. Dialysis? No. Diffusion? Yes. Osmosis? No. A region of higher concentration to a region of lower concentration. Osmosis is osmosis is movement from a region of lower concentration to a region of higher concentration. Osmosis is particle will diffuse. I mean, a particle will move from a region of a low concentration across a semi-permeable membrane to a region of higher concentration. So it is not even osmosis because region of high concentration to a region of lower concentration, that's not a thing. So what will happen here will be diffusion. Diffusion is the right answer because it's not osmosis. Osmosis is the reverse. So diffusion for 23, answer is diffusion. That is C. Number 24. Which of the following gases has the least rate of diffusion under the same condition? The least rate of diffusion. We have sodium, nitrogen 4 oxide or nitrogen dioxide. We have carbon 4 or carbon 4 oxide, or what we call carbon dioxide. We have sulfur dioxide, and we have hydrogen sulfide. Okay, which of the following gases has the least rate of diffusion? Okay, for them to diffuse, the mass or the molecular weight has a role to play in their diffusion. for them to diffuse their mass, their molecular mass, or their weight, molecular weight, has a role to play. The larger the molecular weight, the lower the diffusion, or the slower the diffusion. So let's first of all look for the molecular weight of this. We have nitrogen dioxide. Nitrogen dioxide is there. The nitrogen dioxide, if we calculate all this, what we are going to have is sulfur dioxide have the highest mass. So I will summarize and say the rate of diffusion decreases with increasing molecular mass or molecular weight. So after calculating all those one, sulfur dioxide has the highest MR, that is the highest molecular weight. Sulfur dioxide has the highest molecular weight, which is 64 grams per mole. And for that reason, sulfur dioxide will be the one that will diffuse slowly, very, very slow. So our question was, which of the following gases has the least rate of diffusion through the same condition? All things being equal, the one that will diffuse has the least rate of diffusion. The least rate of diffusion will be sulfur dioxide because it has a higher molecular weight. So our answer for 24 is C. Now let's go to question number 25. Fractional distillation is a technique generally used for the separation of A. Miscible liquids with close boiling point. Miscible liquids with close boiling point. Miscible liquids. Remember, fractional distillation, it is arranged in such a way that the different liquids there or the different hydrocarbons there are separated based on their temperature, on their different temperatures. So the different temperature or different boiling points. So now, being a miscible liquid with close boiling point, that answer is right because it is based on the different boiling points that are being separated at different level of different levels of boiling points. That is how the hydrocarbons are being separated. But B, answer B is only miscible liquid, so that one has no is not appropriate. Two liquids with different density. There are not only two liquids in the fractional distillation column. It's not like that. Two liquids with different molar masses. That's not the thing. So the appropriate answer for this is miscible liquids. These are miscible liquids because you cannot separate them. They are mixed up together. The only way you can separate them is through the fractional distillation of fractional distillation with close boiling points. So this one B, which is immiscible liquid. Immiscible liquid is it has no. They are not. It is. They are all miscible. They are all miscible. That's why we are using the boiling point to separate them there. So the fractional distillation chamber is fractionalized in order of boiling points. Hydrocarbons of a particular boiling point are distilled. Hydrocarbons of different boiling points are distilled at their various boiling points. So the right answer for question number 25 is A. Question number 26. Hess's law states that the total enthalpy change for a reaction is 1. Independent of the path taken. That's great. Remember, there's something there lacking. It is independent of the path taken or independent of the route taken, provided the initial and the final conditions and the states of the reactants and products are the same for each route. Provided the initial and the final conditions and the states of the reactants and the products are the same for each route. So, according to Hess's law, they say that the total enthalpy change for a chemical reaction is independent of the path taken or the route taken. That one is right. Dependent, no. Change, no. Always constant, no. So A is the right answer, independent of the path taken or the route taken. So 26 is A. 27. The pH of wastewater from a factory. The pH of wastewater from a factory was found to be 3.2. Remember, 3.2 is acidic. pH of 3.2 is acidic. So the pH of wastewater from a factory was found to be 3.2. Which of the following substances could be used to neutralize the water before it is released into the river? Okay. Now, that is acidic. We will need something alkaline to neutralize this. So, which of the following substances? Ammonium tetraoxosulfate. Ammonium tetraoxosulfate is not the right thing. It will not be used for that. That is ammonium sulfate. It will not be used for that. Lime. Lime is calcium hydroxide. Lime is calcium hydroxide. And calcium hydroxide is highly alkaline. Calcium hydroxide is highly alkaline. It has a pH of, I think, about 12, above 12. Sulfur 5 oxide. Sulfur 4 oxide. That is sulfur dioxide. Yes, this one is acidic gas. That is sulfur dioxide. Sulfur 4 oxide is sulfur dioxide. This is an acidic gas. An acidic gas cannot be used to neutralize an acidic condition again. So this is an acidic. A pH of 3.2 is acidic. So we need an alkaline substance. So this one is not right. Lime is right. Lime is calcium hydroxide and it has a pH of above 12. Sulfur 4 oxide, that is sulfur dioxide, is an acidic gas. It cannot do that because it is acidic. Triazonitrate 5, it cannot do that. So the appropriate answer here will be B. Listen, pH 3.2 is acidic wastewater. Lime water, that is calcium hydroxide, with a pH, because it has a pH of 12.4, will neutralize it. This lime water is alkaline. It has a pH of 12.4. So this is the only right thing that can be used to neutralize a pH of 3.2, which is acidic. So lime is the right answer. B. 28. 28. The salt MgOHNO3 is an example of A. Normal salt, B. Double salt, C. Complex salt, and D. Basic salt. It's a basic salt. It's a basic salt. This is a basic salt. 28, this is a basic salt. And 29, which of the following oxide is neutral to moist litmus paper? Neutral to moist litmus paper. Neutral to moist litmus paper. Water to moist litmus paper, no. Neutral to moist litmus paper. Which of the following oxides? Carbon dioxide is acidic, no. Sulfur trioxide is also acidic, neutral. The neutral oxide here will be nitrogen dioxide. It will be nitrogen 4 oxides. It will be nitrogen 4 oxide, which is a D. Thank you, fellow learners. We will continue with question number 30 on our next session. Question number 30, we will continue with question number 30 on our next session. Thank you for listening. Once more, if you haven't subscribed to our channel, please, what we need from you as our support is like the video, share to other learners, and most importantly, take your time and subscribe to our channel for more other videos on these questions and answers. Thank you.